Welcome back to Great Coffee Mathematics Cape Syllabus. Today we're going to be discussing Unit 4 on functions. So we're going to deal with function notations, graphs, inverses, and logarithms. So functions is more like fx is equals to, transforms into y. So in this chapter or a unit, we're going to deal with functions. For example, fx is equals to 2 plus 1. So this is a function. So if you say f1, it means you're substituting x for 1 like this. Therefore, f1 is equals to 3. Then we also look into graphs. For example, if you say y-axis and x-axis, if we want to draw y is equals to 2, so it means when x is 0, y is 1, so is 1. When x is equals to 1, y here it was 1, y is equals to 3. Y is equals to 3. So here I can do it like this. So that I increase it. No, sorry. So 2, 3. Then I'll take the y up there. So we said when x is equals to 0, so 0 is here, then y is equals to 1. When x is equals to 1, y is equals to 3. Right, so this is minus 1, 2, minus 3, 1, minus 2, 3. Let's say if x is equals to minus 2, so that will be 2 minus 2 plus 1, and that's minus 3. So when x is equals to minus 2, so it's equals to minus 3 somewhere. So remember this is not up to scale, so when you draw it will be something like this. So that maybe I can use a different color to make it more visible. I can delete okay, let me just draw on top of it. You see, so this will be like y is equals to 2x plus 1. So it's more like a graph. Then inverses and logarithms, we're going to discuss them further. But I just wanted to introduce to you that in this unit, you're going to deal with function notation, graphs, inverses, and logarithms. So let us move on. Learning outcomes. So from this chapter, the expected learning outcomes, so what learners should be able to do by the end of this chapter. So they should be able to use function notation and evaluate function values. They should be able to determine domain, range, x-intercept, and y-intercepts. They should be able to sketch, interpret linear, quadratic, hyperbolic, and exponential, as well as logarithmic graphs. They should be able to find inverse function, identify when a domain restriction is required. Then they should be able to use transformation, asymptotes, interceptions, and to solve graph-based problems. So the unit, we have a function idea, graph features, families of graphs, inverses and logs, and applications. So that's how we're going to approach this chapter. So let's move on. So what is a function? So a function is a rule that gives exactly one output for each input. So we put an input x, then there's a rule, which is the function, then it produces an output, which is y. So a definition, a function, a relation is a function only if every input value has one output value. So one input to give one output. Then different inputs may produce the same output, but one input may not produce two outputs. For example, you can input x and it gives you y. You can put z, then it gives you y. So what we are just meaning is like one input should produce one output. One input should produce one output. Not you put n, then you come with the x, y, z, three outputs. We only say one in, one out. You understand? So that's what it means. So the example that I've already given you, fx is equals to x plus 1. So if you say x is equals to 4, then f4 is 2 times 4 plus 1. So it becomes 8 plus 1 is equals to 9. So this is how you solve. We have already covered substitution and all those things in the previous unit. So function notation. So fx means the value of the function at x. So x is just more like a placeholder. It's a placeholder. So x can be equal to 1, x can be equal to 2. So you just work according to what the question is asking you. So for example, let's look at the following function. Fx is equals to x squared minus 4x plus 1. So we are asked to evaluate f3. So it means where there is x, we are substituting to 3. In other words, x is equals to 3. So we substitute into this equation, then f3 is equals to 3 squared minus 4 times 3 plus 1. Then you simplify, 3 squared is 9, 4 times 3 is 12, then it becomes minus 4 times 3 is equals to minus 12 plus 1. So when you simplify, you get minus 2, right? Because 9 minus 12 is minus 3 plus 1, then you get minus 2. So that's how we get to this answer. So the important notation point is that fx is not multiplication. It is a label for output produced by the function rule when the input is x. So it's a function rule, not a multiplication. So for example, if we say fa plus 2, it means we are where there is remember it's normal fx. So if you say fa plus 2, it just means we are saying x is equals to a plus 2. So when we take this a plus 2 and put it here in the function, let me do it here, fx minus 4 plus 1. So f a plus 2, it means it's a plus 2 in bracket squared minus 4 in bracket a plus 2 in bracket plus 1. So that's how we get here. So it just means you're substituting. So examiners often test substitution using algebraic inputs such as a plus 2, not only numerical numbers. So sometimes you are asked to find f1, and sometimes it can be found, say, fa plus 2. So it's not always numbers. Sometimes they give you algebraic expressions, inputs instead of numerical inputs. So you should be cognizant of such things. So let's move on to the next. Domain and range. So domain is the possible inputs, then range is the possible outputs. So domain reads the x values from the left to the right. It answers which inputs are allowed. Then range reads the y values from the bottom to top. It answers which output values are possible. So in other words,